Hello everyone. So let me discuss to you Gay-Lussac's law. So Gay-Lussac's law was formulated by the French chemist named Joseph Gay-Lussac in 1808, and according to his law, the pressure exerted by a gas is directly proportional to the temperature of the gas when the mass is fixed and the volume is constant. So what do we mean by that? So here I have PET simulation to show you the relationship between the temperature and pressure of gas at fixed amount of gas and constant volume. Okay? So tingnan natin dito sa simulation kung anong mangyayari kapag nagbago ang temperature, anong magiging epekto niya dito sa gas pressure. Okay? So I have here a source of heat. Okay? And of course, what you will observe in this simulation, we're going to relate it also to kinetic molecular theory. Remember, in kinetic molecular theory, if there is an increase in temperature, there will be an increase also, or it is directly proportional sa average kinetic energy ng gas molecules. Okay? So, tingnan natin kung anong mangyayari. So, increase natin ang temperature. Okay? And observe din nyo ang movement ng gas molecules. Okay? So, initially, meron tayong negative 268 degrees Celsius. Ang pressure natin dito, pressure reading is 0.0 atmosphere. And as you can see here, yung movement ng gas molecules, gumagalaw sila, nagmo-move sila. They have kinetic energy pero hindi masyadong mataas. Okay? So, that's why they are moving very slowly. No? Mabagal yung kanilang movement. So let me increase the temperature and watch what will happen sa pressure and sa gas molecules, sa movement ng gas molecules. So I'm now increasing the temperature. Okay. And as you can see, as temperature increases, pressure will also increase. So nag-i-increase din ang pressure. And of course, look at the movement of the gas molecules. Remember, as temperature increases, the average kinetic energy will also increase. Okay? So let me continue increasing the temperature. Habang nag-i-increase si temperature, nag-i-increase din ang gas pressure. Okay? At mangyayari lang yan kapag constant yung amount of gas, yung mass ng gas at volume. Okay, let me just stop. Okay. Now, let's see what will happen if I decrease the temperature. Anong mangyayari din sa pressure? So, let me decrease the temperature. Okay. Observe kung anong nangyayari sa pressure kapag nagde-decrease yung gas temperature. And look at also the movement. Anong nangyayari doon sa movement ng gas molecules inside the container? So, as you can see here, as temperature decreases, pressure also decrease. Okay? Nagdi-decrease din. Okay? And yung kinetic molecular energy, bumababa din. Or bumabagal yung movement ng gas molecules. Okay? And that is according to Gay-Lussac's law. Okay? The relationship between the pressure, is directly proportional to the temperature of the gas when the mass is fixed and the volume is constant. Or if you will make a graph of the relationship between temperature and pressure of gas, it will look like this. Okay? So, data for temperature, dito ilalagay sa my x-axis. And of course, data for pressure, ilalagay dito sa my y-axis. So, clearly, you will have this kind of graph, which means directly proportional yung relationship between temperature and pressure of gas, as long as, again, constant yung volume at amount of gas in moles. Okay? So, kung magdi-derive tayo ng, if we will show the relationship between temperature and pressure in equation form, for the Gay-Lussac equation, we could say, we can write it like this, where K means constant. So So, yung constant dito ay yung amount of gas in moles, yung small, yung letter N means number of gas, and then yung volume ng gas, constant yung dalawang yan. So, ibig sabihin, hindi nababago. Kahit na may nabago sa temperature at pressure ng gas, ito, constant pa rin. Hindi nababago. So, we could say that pressure of a gas is directly proportional sa temperature at K constant. Okay? Or pwede natin itong i-write. Let me just fix it here. Okay, pwede natin i-write where pressure over temperature is equal to K constant. Okay? So, since hindi nababago si K constant, okay, so if we have initial pressure, okay, over initial temperature in Kelvin, it is equal to K constant. Okay? Same din, kung meron tayong final pressure over final temperature, okay, so it is still equal to K constant. Okay? Since parehas ito, initial pressure over initial temperature is equal to K constant, same here, kahit na nabago si pressure at temperature, it is still equal to K constant. So we can rewrite, okay, the equation where P sub 1, which is initial pressure, over T sub 1, which is your initial temperature, again, it should be in Kelvin, is equal to P sub 2 over T sub 2, which is your final temperature. So this is now our Gay-Lussac equation, which you can use, okay, in solving sample problems related to behavior or properties of gases, as long as constant yung volume at amount of gas. So let's have sample problems using Gay-Lussac equation. Okay, so here we have our problem number 1, which is the gas in an aerosol can is under a pressure of 3.00 atmosphere at a temperature of 25 degrees Celsius. It is dangerous to dispose of an aerosol can by incineration. What would the pressure in the aerosol can be at temperature of 845 degrees Celsius? Okay, so remember, aerosol can must be disposed properly because, again, remember, gases, properties of gases will change if they are exposed or there will be change in the environment. Okay, so let's have this example here. So first thing is, of course, we need to identify the given, and of course, we will assume that the number of gas or the amount of gas and of course the volume constant or fixed or hindi nababago. Okay, so the only properties of gases that are changing would be the temperature and pressure. So here we need to find the pressure. Okay, since we have now our given here, okay, initial pressure, initial temperature, and final temperature, and again we're looking for the final pressure, and we have our Gay-Lussac equation here. So we need to derive the equation, okay, to find final pressure from the Gay-Lussac equation. But before we do that, okay, we have to convert. Okay, always make sure that in any gas law problems, you have to make sure that the temperature must be in Kelvin. Okay, if you're going to substitute or use it to solve a gas law problem, ang temperature dapat naka-convert siya into Kelvin. And of course, to do that, okay, you have to add 273.15 Kelvin, okay, sa value ng temperature in degrees Celsius. So let's have the value of initial temperature. So for our initial temperature, okay, it will be equal to 25 degrees Celsius. Okay, add natin ang 273, okay, 0.15 Kelvin. Okay, so our initial temperature in Kelvin, that is equal to 25 plus 273.15, that is equal to 298. Okay, 298.15 Kelvin. Okay, so again, convert lagi ang temperature in Kelvin. For our final temperature, okay, same also. So we have 845 degrees Celsius plus 273.15 Kelvin. Okay, so let's add 273.15 Kelvin. Okay, so 845 plus 273.15, our final temperature in Kelvin is equal to 1118, okay, 0.15 Kelvin. Okay. So since na-convert na natin yung temperature natin from degrees Celsius to Kelvin, we can now substitute it in our equation. So this is our Gay-Lussac's equation. And since we're looking for the final pressure, magdi-derive tayo. Okay? So let's have, okay, P sub 1 over T sub 1 is equal to T sub 2 over T sub 2. So our derived equation will be final pressure, okay, is equal to, okay, remember we will be transferring this here. So we have P sub 1 or initial pressure times final pressure in Kelvin over initial temperature in Kelvin. So ito na ngayon yung ating derived equation to find the final pressure. So we can now substitute our given here, our known values here. So final pressure is equal to, for our initial pressure, we have 3.00 atmosphere. Okay. And of course, our final temperature is 1118.15 Kelvin. Okay. And for our initial temperature, it is 298, okay, 0.15 Kelvin. So definitely, yung unit na Kelvin ay maka-cancel. At ang matitirang unit lang ay yung unit ng pressure, which is atmosphere here. So first thing is, let's multiply. Okay, multiply natin yung initial pressure at final temperature. Okay, so we will have 3.0 times 1118.15 Kelvin. That is equal to 3,354, okay, 354.45. So, sulat natin eksakto lahat ng digits na mag-a-appear sa ating calculator or gadget. And then over 298.15 Kelvin. So divided by, okay, divide natin 298.15. So our pressure, final pressure, okay, is equal to 11.25 or 11.3 atmosphere. Okay, na-run off na natin. So this is our final pressure. Okay, at constant volume and fixed amount of gas. Remember the relationship between temperature and pressure. Okay, directly proportional. So, actually, we can predict based dito sa ating given. Remember, since directly proportional yung relationship between temperature and pressure of gas. Since we know na nag-increase yung temperature, obviously, nag-increase si temperature from 25 degrees Celsius to 845 degrees Celsius. So, since nag-increase si temperature, we expect that pressure will also increase. So, as you can see here, from 3 atmosphere to 11.3 atmosphere. Okay, so here's another example problem. We have, if a gas is in a closed container, is pressurized from 15.0 atmosphere to 16.0 atmospheres, and its original temperature was 25.0 degrees Celsius, what would the final temperature of the gas be in degrees Celsius? Okay, so again, we will assume na constant yung amount of gas at saka yung volume. Okay, so we have our given here. Okay, we're looking for the final temperature, and of course, our gas law equation will be yung Gay-Lussac's equation. So for our solution, okay, again, since meron tayong initial temperature dito, we have to convert it first in Kelvin. Okay, so let's okay, for initial temperature, okay, we have 25 okay, degrees Celsius plus 273 okay, 0.15 Kelvin. So our initial temperature in Kelvin is equal to 25 plus 273.15, that is 298 okay, 0.15 Kelvin. So again, always make sure na naka-convert ang ating temperature in Kelvin. Okay, not in degrees Celsius or degree Fahrenheit. It should be in Kelvin. So since we've already converted our temperature in Kelvin, now we don't have any problem when it comes to the unit for pressure kasi naka-atmosphere. Yun din yung isang titignan nyo kung parehas yung unit, okay, ng mga given, okay, especially here for pressure. So naka-atmosphere, so we don't need to convert. So let's substitute or let's place these given sa ating equation. So we have, again, we have our, okay, Gay-Lussac equation for our solution. And since we're looking for the final temperature, let's derive. Okay, so we have final temperature, okay, is equal to, we have final pressure times initial temperature over initial pressure. Okay, so let's substitute our given here. So we have our final pressure, which is 16.0 atmosphere. Okay, for our initial temperature in Kelvin, it is 298, okay, 0.15 Kelvin over initial pressure, which is 15 at 0.0 atmosphere. Okay, 15.0 atmosphere. So definitely yung unit ng pressure, which is atmosphere, makakancel yan. Okay, so let's multiply first. Okay, multiply natin yung initial pressure, 16.0 atmosphere times 298.15 Kelvin, that is 4,770.4, okay, over 15 divided by 15.0, our final temperature, which in Kelvin unit is equal to 318 Kelvin. Okay? We're not yet done kasi ang ating sagot dapat ay naka-degree Celsius. So to convert temperature from Kelvin to degree Celsius, all we need to do is subtract or minus tayo ng 273.15 Kelvin. So we have temperature The final temperature here, which is equal to 318 Kelvin minus 273. Okay, 273.15. Okay, para ang magiging final answer natin, okay, naka-degree Celsius na. So, 318 minus 273.15, that is 44.85. This time, yung unit na ng ating temperature ay degree Celsius. So, eto na yung ating sagot ngayon. Okay? For our final temperature in degrees Celsius. So, again, we can always make prediction. Okay? So, here, for our given, obviously, yung ating pressure ay nag-increase from 15.0 atmosphere to 16.0 atmosphere. So we expect also that our temperature will increase. So here from 25 degrees Celsius now, our final temperature is 44.85 degrees Celsius. Thus, it is true that the relationship between pressure and temperature of gas at constant volume and fixed amount of gas is directly proportional.